Good morning, everyone, and welcome to yet another first flight. Today, as always, we have a really interesting project I want to show up. And I always say all of these first flight projects are really interesting, and the reason is because they are. We have explored a lot of different topics on these first flights, from NFTs, ERC20s, thematic first flights like the San Valentin and Christmas ones, and today we are going to explore yet another interesting topic, which are cross-chain transactions without using a bridge. So, as always, I recommend you to go to CodeHouse and open this first flight to get in touch with what's happening there. I'm going to actually copy and paste this on the chat for anyone interested on giving this a shot, and let me put this also on the screen. So I'm going to share my screen right now. Before we get started with this first slide, I need to give a big shout out to Shikar. He is the one who submitted this first slide for the community. So please go ahead to his Twitter, Shikar229, and give him a follow, and also follow him on GitHub as well. He has been a really superstar for the community, and his accounts are not receiving that much love. So please remember to follow him because he was the superstar who submitted this first flight for us. Okay, let's get started then with this first flight. Let's go again to the first flight page. And on this project, we are going to have a Kitty Connect contract or a Kitty Connect marketplace, which is a way to mint some standard ERC721 tokens, with the difference that we are going to be able to send these NFTs cross-chain without using a bridge, thanks to Chainlink CCIP, which is a technology I'm going to talk a little bit further later on this first slide presentation. As always, don't forget to view the repo on GitHub. I'm going to get for granted that you already know how to clone this, and also open your terminal and install the dependencies with make install. I already have them, of course. And let's return to the contest page. So basically, these first flight, as always, are going to give you some points depending on the vulnerabilities you find. It has an ends-log of 235 lines of code. The complexity is 193. And about this project allows users to buy a cute cat from our branches and mint NFT for buying a cat. The NFT will be used to track the cat info and all related data for a particular cat corresponding to their token IDs. Kitty owner can also bridge their NFT from one chain to another via Chainlink CCIP, as I already said. Let me remove this. This first slide has two contracts on the scope, kittyconnect.sol and kittybridge.sol. The important roles here, and yes, because this contract has some sort of ownability, is the roles for each type of user. First, we have the cat owner, is the user who buy the cat from the branch and mint the NFT. The shop partner, this provides the service to the cat owner to buy the cat. And the Kitty Connect owner, which is the owner of the contract who can transfer the ownership of the one contract to another address. So again, as I said, I'm going to get for granted that you already clone the repo, install the dependencies, and compile all the project. One of the important parts before I get started on the actual intricacies of the code is this known issue. There is an unknown bug while breaching the NFT to other chain. The previous owners of the cat are not passed because they may cause a large amount of gas. This means that, for example, if you see any NFT on a marketplace like OpenSea, you have the historic values and owners that NFTs has alone, like which account transfer that NFT to which account. This is a known issue for this first flight because storing all this information to the new chain would be really like cost expensive. So don't mind that if you find this as a problem because this is already a known issue. So let's get started and actually explaining how this code project works. So I'm going to open my code editor, Visual Studio Code as always, and this is the main contract. As you can see here, this is kind of plain standard ERC 721 token contract in terms that you're not going to find something really crazy here. Is a standard ERC 721 token, which has a struct with the cat info, with the image, the breed, the cat name. Of course, all this information is stored as a token URI, decoded in a base 64 information. And we have, again, these modifiers for the ownability, the only kitty connect owner, the only shop partner, and the only kitty bridge, which are the roles I already explained on the documentation. And we have here the min cat to a new owner is a standard minting functionality for a standard ERC 721. But then we have other functions. Well, the safe transfer form, again, if you want to send your NFT to another user on the same chain, sorry. And then we have this important part, bridge NFT to another chain. This is going to have a destination chain, a destination bridge or chain bridge, and also the token ID we want to send over. This information is going to basically burn the NFT on the base blockchain and then mint a new one on the destination one. So you burn the NFT, for example, on the Ethereum blockchain, and then you mint a new one on the Polygon one. Basically, this at the end is going to call this function bridge NFT with data, which relates to the kitty bridge.sol. This contract is not that hard to understand actually. It just have 131 lines of code, but this gets kind of crazy because wait a second, we need to have someone called EVM to any message, and we need to have a iRouter client, so we have to route our NFT to the new chain, and we have a lot of weird functions. What's worse is that if we click on the Solidity Metrics extension over here and we go down to the call graphs, look this mess. This bridge NFTs with data is going to call all of this information at once. And this is kind of strange, right? Like an S-Link token, which seems to be ERC20, the EVM to any message, which is the client. And okay, this is kind of hard to understand. So in this part is where we are going to talk about CCIP or Chainlink CCIP. But before I delve directly into that, I'm going to give you a slight note on blockchain bridges. You might be thinking, okay, but why do we need to use Chainlink CCIP to start with, right? We already have blockchain bridges. I can easily go to one bridge, log my assets, and receive the corresponding token on the new bridge, right? And yes, you are right, but centralized blockchain bridges are a liability most of the times. The reason is because taking all the technicalities outside, what you are doing is actually sending your assets to a random smart contract, and the owners of that smart contract are promising you that they are going to lock that assets for you and then mint the corresponding new assets on the specific blockchain you want to bridge to. What's the problem? Well, let's take a look at this. If you see the direct leaderboard, you are going to see that, for example, running network was a bridge, BNB bridge, again, another bridge, and a lot of the top hacks on the industry had happened on blockchain breaches. The reason is because as they are centralized, they are a really nice target for attackers and malicious actors. I mean, they secure millions and millions of dollars. And what Chainlink CCIP is trying to do is for you to not rely on a centralized bridge to manage your assets, but instead trust a decentralized Oracle network, the Chainlink Decentralized Oracle Network. How Chainlink CCIP works deeply is a little bit outside the scope of this first flight presentation, but I'm going to give you some nice resources here and there for you to get started. First, I highly recommend you to check Patrick Collins' video about what CCIP is. I'm going to actually link that on the comments as well. It's just a 3 and 47 minutes long video, which has an interesting explanation about what Chainlink CCIP is. I highly recommend you to check that. And in terms of structure or architecture, Chainlink CCIP is something like this. You have the source blockchain, you have the sender smart contract, which is sending the tokens, or in this case, NFTs. You have a token pool. This token pool is based on link token or Chainlink link token. All the decentralized network of Chainlink is going to create that transaction, and you have a destination contract on the other chain to receive those tokens. Again, explaining how this works deeply is a little bit outside of the scope of this first flight, but again, I highly recommend you to go to the Chainlink CCIP documentation. They have a really nice guide to getting started. Pre-made contracts on Remix, you can always check and get more in touch on how the base chaining functionality works. So basically, at the end of the day, let me return to the code. The Kitty Connect allows you to bridge the NFT to another chain. This is going to call Chainlink CCIP to burn the main token on the base chain, send that token to the destination chain, and meet them right over. That's why we also have another function called min bridge NFT, which is an external function which can be only be used by the bridge itself. Remember, if you want to send this transaction from one chain to another, the thing you have to do is deploy this contract on the base chain, in this case, let's say Ethereum, and then also deploy the exact same contract on the destination chain, let's say Polygon, in order for that function to be able to be called the min bridge NFT. With that said, let's check what a security researcher might be looking for on this case. Of course, don't forget to always run a forge coverage to see what are the amount of tests this contract takes care of. Oh, look at this. We have some warnings, a good starting point. And also we see that the smart contracts on the scope, the Kitty Bridge and the Kitty Connect.sol, doesn't have all the coverage for the functions, 90% and 76%. So also don't forget to check out those tests in order to start finding some behaviors that aren't supposed to happen. Other thing you might be start looking for is that, remember, this smart contract has these roles. Uh, Cat owner, shop partner, and Kitty Connect owner. It means that some specific functions are only meant to be used by these specific roles. You can also start looking forward to, okay, how can I make a specific function to behave as the function is not expected to behave by overpassing these roles? And well, other things that you as a auditor might already know. Of course, we don't want to spoil the solutions and the actual vulnerabilities to this smart contract, but basically remember, this is a standard-ish RC721 token, which allows you to mint cute kitties, but with the extra functionality of using Chainlink CCIP to send cross-chain transactions in order to be able to mint those NFTs on a destination chain. And that was it for this first flight. I hope you enjoyed this so far. Remember, you can always contact us asynchronously on Discord, or community manager superstar Echios is going to be more than happy to assist you if you have any question. And don't forget to follow Shikar again, because he is the one who sent over this first flight, and their accounts deserve more love. And yep, that was it. Please don't forget to leave any comments on questions on Discord, and I'll see you on the next occasion. See ya, everyone.